Welcome to Unit 10, Lesson 4, Solving Trigonometric Equations Using Identities. Now that we understand how to apply trigonometric identities to solve problems and to prove that the solutions are true for values of x, what we're going to do is work on solving these equations algebraically. So in this sense, what we're going to do is find the actual values of x. In our first example, A, solve by substituting trigonometric identities and factoring. So it says solve each equation algebraically over the domain of 0 is less than or equal to x is less than 2 pi. In the first question, cos 2x plus 1 minus cos x, we can replace that double identity with 2 cos squared x minus 1. And that comes off of your formula. So it's this one right here. Oops. This one right here. This comes off your formula sheet, and it's this one right here. Cos 2a equals 2 cos squared a minus 1. So you just fill this value in wherever there's a cos 2a. And then we simplify. So we have minus 1 plus 1. That, of course, cancels to 0. So you're left with 2 cos squared x minus cos x equals 0. Next step is to factor out a cosine x. That will leave you with two terms. We have cos x equals 0 or 2 cos x minus 1 equals 0. From here, you want to just consult your unit circle and find the values of cos x that this statement is true for. So cos x equals 0, that's true at both pi over 2 or 3 pi over 2. And 2 cos x minus 1, or cos x equals 1/2, is true at pi over 3 or 5 pi over 3. So this question here actually has 4 solutions to give the correct answer. All of these values are defined for x. In part B, I just wanted to remind you that the sine function cannot exceed a value of 1. So now that we have that in our minds, what we can do is solve and replace the sine squared x. Here, this is one of our Pythagorean formulas, 1 minus cos squared x. So that's equal to sine squared x. And then we're just going to isolate all the variables over to the left-hand side. So sine squared x minus 3 sine x plus 2 equals 0. Factor sine x minus 1, sine x minus 2. In this bracket, we get sine x equals 1, and therefore x equals pi over 2. In the right-hand bracket, we get sine x equals 2, and you can just say no solution there. And my explanation is sine cannot be greater than 1. Not be equal to greater than 1. In part B, solve an equation with a quotient identity substitution. Basically, all this is saying is if you get tangent or cotangent in your formula, replace it with either sine x over cos x or cos x over sine x, depending on which one you're given. So in this question, we have cos squared x equals cotan x times sine x, and you just simplify out. So cos x over sine x, these two multiply and cancel. We get cos squared x equals cos x. Isolate the variables to the left-hand side, so cos squared x minus cos x. And then factor out a cosine x, and then your other factor is cos x minus 1. And therefore, cos x equals 0 or cos x equals 1. Now, these statements are true for cos x equals 0, x can equal 90 or 270. And for cos x equals 1, x equals 0 degrees. Our domain is from 0 to 360. So the only thing you need to consider in this problem is the fact that you have a non-permissible value for cotan x. And that occurs when the bottom of the fraction, of course, is undefined. So if you look up here, sine x cannot equal 0. That will give you an undefined answer. Therefore, x can't equal 0 or 180. And then because of that, the only valid solutions for this problem are x equals 90 and x equals 270. X equals 0 unfortunately becomes a non-permissible value in this situation. So just consider your unit circle to help you out, and then also just look in the fraction part of your question that you're given to see if there's any spots where x can't equal 0. In part C, determine the general solution for a trig equation. So sometimes we'll just be asked to figure out what's the general solution, how many times can we rotate around the circle and at what increments. So in this question, sine 2x is equal to root 2 cos x. Now you have that double angle identity. You're going to replace the sine 2x with 2 sine x cos x equals root 2 cos x. And then isolate all the variables to the left-hand side or the right-hand side, whichever way you work, it's correct. But I like to move to the left. It just works for me. Once we're here, you're going to isolate out the cosine x by dividing all terms by it. So you're left with two terms. You're left with cosine x equals 0 or 2 sine x minus root 2, which when you figure it all out, sine x is equal to root 2 over 2, which should look familiar to you. So when cos x equals 0, x is equal to pi over 2 plus pi n, because remember that this is 90 degrees, and then it also occurs again, cosine x equals 0 at 270 degrees. So it's not 2 pi n here, it's just pi n. It'll happen every 180 degrees. Sine x equals root 2 over 2. You're going to have two values for that where the root 2 over 2 is positive, and that's in quadrants 1 and 2. So just look at your unit circle, find root 2 over 2 where it's positive. Then we have a solution, x is equal to pi over 4 plus 2 pi n. So you just go all the way around the circle an extra time to get to that next coordinate. And then it also occurs at x equals 3 pi over 4 plus 2 pi n, where n is any integer. So general solution, don't forget how to write that out. The last question, determine the general solution using reciprocal identities. Algebraically solve 2 sine x equals 7 minus 3 cosecant x. Again, just like when you use cotangent and tangent, you're just going to take the reciprocal identity and break it down into its component parts. So we know that cosecant x is equal to 1 over sine x, and we just want to break that 3 cosecant x term down into that to get our question started. On the left-hand side, we have 2 sine x. That can stay as is. On the right-hand side, we have 7 minus 3 over sine x. Now, very important, we need to multiply all terms in this equation by sine x so that they have a common denominator. Essentially, we're eliminating this fraction here. So this sine x is multiplied by both terms in the brackets. Don't forget about this distributive property. So it's sine x times 7 and then sine x times negative 3 over sine x. And of course, whatever you do to the right-hand side, you also have to do to the left. So that's where this one comes from here. On the left-hand side, we end up with 2 sine squared x is equal to 7 sine x minus 3. Once you're at this point, you just isolate all the variables to the left and then factor. So 2 sine x minus 1 and sine x minus 3 will be the factors of that equation. And then we just solve for each factor. So sine x equals 1/2 or sine x equals 3. Now this side, the second one, gives you no solution. Sine x cannot equal 3. If you don't believe me, you can just punch it in your calculator and you will get an error response back. In the left-hand factor, you have sine x equals 1/2. So again, you just consult your unit circle and find that x can equal pi over 6 plus 2 pi n, or it's still positive in the second quadrant, x equals 5 pi over 6 plus 2 pi n. So those would be the two solutions for this problem. Beyond this, you have 4 practice questions and you can prepare them for class tomorrow.